The length of the nail below is measured to be 5.750 centimeter. How many sure figures are there in the measurement? Choose the correct answer. Okay, here to solve this number, let's first talk about the sure number and estimated number. So for the sure number, let's say we have here 5.750. The sure number will be this 3 digits, and the estimated number always will be the last digit in any number. So here I have sure figures, and the last digit in any number will be estimated figure. Okay, so to answer this question, for this number I have 1, 2, 3 sure figures. So let's say if I have another number, let's say 6.70 or 71, for example. So the sure numbers will be 6, 7, which are 2 figures, and the estimated one is the last digit, this is the estimated figure, and these are the sure figure. So the answer here will be 3 digits. The width of the can at its center is 5.8 centimeter. Fill in the blank. The number of significant figures in the measurement is significant figures. Okay. To determine the significant figures, we have some rules. We will follow it to get the significant figures. Okay, first of the rule is significant figures are the non-zero digits. So any digit from 1 to 9, it's called a significant figure. Significant figure. Okay, there's number 1. This first rule. Okay, that means any zero will be a non-significant figure. So 0 will be a non-significant. Okay? But there is some conditions here, some exceptions for this digit which 0. The first condition is that if there is a 0 will be between 2 significant digits. For example, let's say if I say 109, so this 0 will be a significant. Okay? So for example, if I have 1006, for example, so now how many significant figure here? I have 1 and 6 is 2, and because the 0 fell between 2 significant figures, so it will be counted as a significant figure. So I have here 4 significant figure. Okay? Another thing, I have something called leading and trailing. So if I have something, a leading zeros, which means that the number will start with 0 digit. For example, 001. So this number will be non-significant figure. Okay? Another thing is called trailing 0. If the number will end with 0. For example, if I have 3010. So this 0 is called a trailing 0, and this will be non-significant. And this 0, because it's between 2 significant numbers, so it will be counted as a significant number. So this one will be 3 significant number. Okay, I have some other exception for the trailing zeros. If the trailing zeros, for example, if I have this number also, followed by decimal number, decimal point, so this 0 in this case will be a significant. If there is a decimal point after 0. Okay? Another thing, if let's say if I have this number 401 0.004. So as long as the number has a decimal point, so the zeros here will be calculated as a significant number. Okay? So that means I have 1, 2, 3, 4, 5, 6, 7 significant number here. So let's find here now. The width of the can, seeing the number of significant figures in the measurement is, how many numbers I have here? I have 2 digits here, right? And these 2 digits, it's from 1 to 9. So that means I have 2 significant figures. So 2 is the right answer. What are the digits directly read out of the scale called? Choose the correct answer. If I have a ruler, for example, from 0, 1, 2, 3, 4, and I here, for example, I have 3.5, and now I have a rod, for example, I'm calculating the rod, the width, the length of the rod, for example. So this rod on this scale will be 3 centimeters, for example. So that means 3 is a sure digit. 3.5 is a sure digit. So any digits directly read out from a scale is called a sure digits. As I mentioned before, let's say if I have 3.76, so the last digit in any number will be estimated number, and the other digits will be sure digit. Okay? Underline the name given to the last digit in any measurement. We mentioned before, any last digit in any measurement or any number will be estimated. A ruler is graduated in millimeter, mm. This stands for millimeter. What is the place value of the last digit you can include in a measurement made by this ruler? I have this ruler here and it's say millimeter. That means it will be 0.1, 0.2, 0.3. This, for example, this is 0 till 1, and then 1.1, 1.2, 1.3, and go to 2. So the measurement made by this ruler, because I'm talking about 1 millimeter, it will be 0.1 millimeter. Circle the number of significant figures in 000 to 512. 000 to 512. We mentioned before that to configure or to get the significant figure, it has to be the significant figure or the significant digit has to be 1 till 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. For zeros, if it's a leading or trailing zeros without dot, it will be non-significant. So here in this case we have this, these are leading zeros. So leading zeros, that means the number start with them with 0, so they are non-significant. So the other numbers, which 2, 5, 1, 2, they are from 1 to 9, So these are the significant numbers, which they are 1, 2, 3, 4 significant number. So the answer here will be 4. Circle the number of the significant figure in 3.5020. Let's apply the significant rules here. We said significant figures from numbers from 1 to 9. So another thing, zeros are non-significant, but if the zero, there is in the zero leading, for the trailing zero, if there is a decimal point, it will count as a significant. If it's a leading zero, for example 001, this will be non-significant. So let's get this number now. 3 is a significant number. I have a decimal point here. So anything after decimal point having 0 will be counted as a significant. 5 is a significant. 0 is between two significant numbers or digit figures. So it will be significant. 2 is significant, and 0 is a trailing 0, but I have decimal point here, so it will be counted as a significant figure. So I have 1, 2, 3, 4, 5 significant figure. So the answer here will be 5 significant figure. The length of a book is given to be 0.350 meter. What is the length of the book in centimeters to the correct number of significant figures? So I have 0.350 meter, and here they need to know the length of the book in centimeters. So we want to convert this one to centimeter. So as we know, then 1 meter equal to 100 centimeter, right? So 0.350 meter, how much it will be in centimeter? So from this case, we'll do a cross multiplication. So let's say this one, I need to know now the length of the book in centimeter, so I call it by x, for example. So means cross multiplication, we'll do cross multiplication here. So 1 multiply x, it will be x, equal 100 centimeter would be multiplied by 0.350 multiplied by 100 centimeter, 100. So here we will make the multiplication here for 0.350 multiplied by 100, so it will be equal to 35.0 centimeter. So the answer here will be centimeter. Okay? Fill in the blank. In a scale reading, so that means I'm using a scale reading like a ruler, for example, the number of sure figures included is equivalent to the ones read directly out from of the scale. The ruler, say I have a rod here, and I have the ruler, and I'm getting the number, the length of this ruler from the scale. So the number of the sure figures included equivalent to the one directly out of the scale, because from the scale I will get the sure figures, right? Like we mentioned before, 35, this is a sure figure. This is 35 centimeters, so this is a sure figure. 3.5 centimeters, this is a sure figure. The number of estimated figure is only 1. Yes, the last number, for example here, this is the estimated All the sure figure plus the one estimated number represent the significant digit. So if I have 3.56, this is a significant digit, right? As we mentioned, the last digit will be estimated digit, and the other numbers will be the sure digit. Okay? Choose the correct answers to complete the sentences below. Okay. 7.5. We have 7.5. How many significant figures here? 1 and 2. So it has two significant figures. Okay. 7.500. How many significant digits here? These are trailing zeros, right? So supposed to be non-significant, but we have a decimal point. So in this case, these zeros will be a significant number. So I have 1, 2, 3, 4 significant numbers. Okay, 0.50. 0.50. Okay, this number is a leading zero. Leading will be non-significant, right? But okay, what about the trailing zero here? The trailing here. Trailing zero here is supposed to be non-significant, but I have a decimal point, so the trailing zero in this case will be a significant number. So I have 1, 2 significant numbers. Okay, 1.2 multiplied by 10 power of 3. Okay, here we will check the number. This we don't need to include it. Or what are we concerned about, or what we want this number? This is 1.2. This is one significant digit, and this is the other significant digit. So I have two significant digits. The length of an object is measured to be 14.5 centimeter. I have 14.5 centimeter. Okay, here, how many significant digits? I have 1, 2, 3. So I have 3 significant digits, right? Okay, what is the sure digits here? The sure digits here are 1 and 4. We already spoke about this in the last examples. Okay, and 5, this is estimated. The last digit in any number is estimated, and this number for 1 and 4 are sure digit, and I have 3 significant digits. So let's hear now. How many significant figures are there in the measurement? I have 1, 2, 3. So I have 3. Underline the estimated figures and circle the sure figures. Sure figures, as we said, it's 1 or 4. Okay, this is the sure figures. And 5 is the estimated. Okay? A student gives an accurate reading of the length of a pencil as 17.6. Okay, here, how many significant figures? I have 1, 2, 3. So I have 3 significant figures. Okay, where is the sure digits? Sure digit is 1 and 7. So I have sure digits. Where is the estimated? It will be the last digit, which is 6. This is estimated, right? So now let's see. Here it's saying number A, the digits in the measurement that are sure. So here, how many digits? We have 2. So the first 2 in the measurement are sure, and those estimated, so it will be the last digit, are the last one only. Okay, the last one will be the estimated. Okay, this measurement contains 3 significant figures. We already got 3. The whole measurement of the length is estimated because I'm doing measurement. So this is estimated. This is not a fact. I'm doing a measurement. So it will be, of course, estimated. Okay. The smallest graduation of the scale deduced from the magnitude of the measured value is, it will be 1 centimeter. This is the small graduation for the scale. Okay. Identify whether each of the following measurements is exact or estimated. Choose the correct answer. Okay, number A, a triangle has 3 sides. Okay, this is a fact. Triangle has 3 sides, cannot be 4, cannot be 2, cannot be 1, so this is exact measurement. Yes. In the 8th grade of the school, there are 65 girls. Okay, that means there is nothing called 65.555 or 64.222 girls. No, it's only exactly it's 65. So this is exact measurement. Okay, the length of the pencil is 7.3 centimeter. Okay, this can be 7.333. So we did rounded, so it will be 7.3. So that means this one is not accurate estimation, because as we mentioned here, the last digit is estimated and the first number is sure. So that means this measurement is estimated. Choose the correct answer to complete the sentence below. A person reports the length of the fish to be 7.4 centimeter. Okay, so the digit after the 4, I don't know it. It can be 1, 2, 3, 4, I don't know actually. So the digit after 4, of course, it's unknown. I don't know about it. Fill in the blank. The dimension of the rectangle are given by 23.6 centimeter and 8.8. Here, 23.6 centimeter. How many significant figure here? I have 1, 2, 3. So these are 3 significant figure. And 8.8 centimeter, this is 2 significant figure. Okay. The number of the significant figure in the rectangle area should be equal to. So for multiplication and division. When we're doing multiplication or division, the significant figure here, the result must be as follows. Here we'll see this number is 23.6, okay, multiply by 8.8, right? So here, the answer of multiplication of 23.6 multiplied by 8.8, it will be 207.68. Okay? Now, to get the significant figure of this number, we will see these numbers. How many significant figure we mentioned here? It is 3, and here it's 2. So for this multiplication, we will take the least significant figure, which is 2 here, and we will apply it to this number. So here in this number, I have 207.68. Okay, so now the significant figure here is 20, right? But what about the other numbers? We have to round the number 0. So we check this 7. So 7 is more than 5. So this 0 will be rounded to 210. So the answer here will be 210. Okay? But the significant will be 2 significant figure. Okay? Because when you get 210, okay, 210, how many significant figure here? It's only 2, because 0 is a trailing number and there is no point, no decimal point, so this will be non-significant. So the answer will be 2. Now, given the rectangle below, I have this rectangle. We need to know the area of the rectangle. The area of the rectangle is length multiply width. So it will be 12 multiply 18. right? So 12 multiply 18, it would be equal to 216 centimeter. Okay. Now, what is the area of the rectangle using significant figures? Let's use the significant figure. So here, how many significant figures in this number? It's 2. And this number also 2. So that means we have to get the number, the result, to significant figure. So how we will do this? I have here 216. So two significant figure, that means 2 and 1. Okay, what about the other numbers? We have to round the number. We have to round the number. So we'll see 6. The next digit is 6. It's more than 5. So this one will be 2. We round it to 2. So the answer it will be 220, right? Centimeter. Okay, but 0 is a trailing digit, so it's not a significant number. Okay, but the answer here it will be 220. So 220, to make it like this one, we will make it as 2.2 multiplied by 10 power of 2. Because if you multiply this number, you will get 220. Round the following measurement to one decimal place. Okay. Now I have 336.87. I need to round it to one decimal place. One decimal place that after the decimal point, you need to round it one decimal place. So here, I have 336.87. Okay. So this is the one decimal place. So check the 7. 7. If we need to round, it's more than 5 or below 5 is more than 5. So this number will be rounded by 1. So it will be 9. And this will be neglected. So it will be 36.9. Okay? Here, 0.617. You want to round to one decimal place, round this number. So check the other next digit. This is below 5. So it will not be, this number will not be rounded. So it will be 0.6. Okay? The two measured quantities 23.6 and 8.8 centimeter are multiplied by each other. How many significant figures should be included in the produce? We answered this before. We said 23.6 multiply 8.8. This here we have how many significant figure? We have 3. And how many significant figure here? We have 2. So we'll take the least number, which is 2. So the answer would be 2 figure. So the result of multiplying 3.6 multiply 8.8, it will be 207.68. But because we have the least number, which is 2 significant figure, so we have to make this number into significant figures, so we can round the number. So I have 2. The second number here, we round it to 1, so it will be 210. This is the answer for this. If he asks for the result of multiplying these two numbers using significant figures. But here is asking for how many significant figures. So I have this number. So let's apply the significant figure rules. We have this is a significant figure, this is a significant figure, this is a trailing 0, and there is no decimal point. So this will be non-significant figure. So I have only 2 significant figure here. Fill in the blanks with the area of each of the following rectangles to the correct number of significant figures. Number A, length 1.0 multiplied by 10 power of 1, and width is 4, which is 4.0, because length multiplied by width, it gives me the area of the rectangle. Okay, now the answer here is 10 power of 1 something here. Okay, now here we have two significant figures, and here will be two significant figures. Even if I add or multiply 10 with 1, it will be 10. Okay, so this is a three significant figure, right? But so I'm going to use the two significant figure, the least significant figure from these two numbers. So here the answer is supposed to be 1 multiplied 4 is 4, right? And here he needs two significant figures, so it will be 4.0. Now, number B, 5.0 multiplied by 3.0, it's supposed to be, the answer is 15.0. These are three significant figures. Okay, how many significant figures here is 2? And here is 2. So this number will make it two significant figures. So we have to round this number. So let's see, the other number here is 0 less than 5, so this number will not be rounded, so the answer will be 15. Choose the answer to complete the sentences. The smallest graduation of the ruler above. Okay, graduation scale of any measurement is the difference between any consecutive number. For example, 1, 0, 2, 1, 3, 2. The difference between them divide by the number of spaces between these two consecutive numbers. For example, let's take 3 and 2 as a consecutive number. So the difference would be 3 minus 2 divided by how many spaces between 2 and 3. Number of spaces I have 1, 2, 3, and 4. So it will be 4. So which will be equal 1 over 4. So now 1 divide 4, it will be equal to 0.25. So the graduation, the smallest graduation here will be 2.5. That means this 0.25 here, it will be 50 and so on. Okay, so we'll move to here, we'll move 0.25, 0.25, 0.25 until we reach 3. Round the following measurement to three significant figures. Okay, 3.901. Here, this number, how many significant figures we have? We have 4 significant numbers. He wants to round this measurement to 3 significant numbers. So I have the number here. So let's move 3 significant number, 9 significant number, and 0 significant number. Goes 0 between 2 significant number. So to round this number, we'll see the number after the 0. This is 1 below than 5, so this number will not be rounded, so it will be the same 3.90 only. This is the answer. Now, round the following measurement to the nearest centimeter. I have the first number, which is 13.7. So let's round this number. So I have 1, 3. So I want to round 3. So we'll check the other number, which is 7. It's more than 5. So this number will be rounded to 1. So it will be 14. Okay, number B, 33.8. So the same thing. I have here 8. This is 3. 8 is more than 5. So this number will be rounded to be 34.